Hello friends, in this video we will talk about smart transportation. Many cities around the world have implemented information and communication infrastructure for management of traffic. Traffic congestion has become a serious problem for rapidly growing cities where a large number of people need to commute on a daily basis and usually rely on their personal vehicles for doing so. Traffic congestion often has predictable patterns such as rush hour traffic that sees huge surge in vehicles playing on the roads over connecting flyovers and bridges also. Also, the lack of parking space is a big cause to be worried about. These patterns become the basis for understanding how traffic can be managed. Sensing for smart transportation involves collecting data on traffic parameters in different ways. One of the widely used methods is that of using camera mounted on traffic signals. Images from these cameras are viewed by people, usually traffic police in large central command centers, from where they inform individual policemen of the extent of the traffic at a particular junction and whether any action needs. Policemen on the ground can then reroute traffic to avoid congestion. An example of this is in Bangalore. The traffic management in Bangalore center. This center receives direct feeds from 180 surveillance cameras mounted on roads across the city. The feed from the cameras is displayed on a massive display screen and individual camera feeds are viewed on smaller monitors. Traffic personnel then instruct traffic policemen on the roads to direct and control traffic in different ways. Another approach is to analyze the images streaming in from cameras to calculate the amount of traffic automatically. The processing system are then able to compute the number of cars on different roads at an instant and also the length of the queue that has built up. This information is then used to directly control traffic signals to slow down or speed up traffic on other roads that are connected. This information may also be used to redirect traffic by flashing messages on road signals and on traffic intersections. The information from surveillance cameras may also be used to identify different types of vehicles. For instance, in some cities, public transport buses are identified, and if there are a number of them at an intersection, then the road they are on is given priority for movement. This logic is also applied to vehicles such as ambulances, police patrol car, other priority vehicles that are enabled to move faster than others. Sensors can also detect bicycles and other such type of vehicles to enable them to cross intersections. Some cities have historically used sensors embedded in the road to detect the presence of a vehicle. These sensors were connected to the traffic signal and the signal would turn green only if a vehicle was present. Modern versions of such sensors sense not only a vehicle but also how many are waiting in the queue and have been doing so far for how long. Based on this information, the signal is controlled. A third method of sensing traffic is by monitoring mobile phones carried by drivers in car. The basic idea is that cell towers for mobile phones near roads will register the mobile phone carried by the driver of the car. If one totals the number of connections to a particular tower, this could be an estimate of the traffic on the road. However, this is a rough estimate as the tower will connect all people nearby, in homes, in offices, walking on the street or in the other places, and they do not contribute to the vehicle traffic. Researchers have shown that sensing handovers, that is movement of phones from one mobile tower to another as the phone is moving in the car, gives a better estimate of how many cars are on the road. This data on the number of cars is aligned with maps of city street, and this shows the flow of traffic also includes the volume of traffic, the direction and the speed at which it is moving. The information is then clubbed with data from cameras to estimate with more accuracy the amount of traffic and how it is likely to create congestion at various points in the city. The latest trend are to use the traffic density and flow information to control traffic signals and traffic direction indicators so that it is available to manage the flow of traffic in the city and avoid congestion. Experiments in some cities in different parts of the world show promising results with up to 25% improvements in travel time. Measuring individual movement of cars and then assessing aggregate traffic patterns requires information technology infrastructure to collect the data from millions of moving vehicles, aggregate it and then performs analysis on it. This is a significant cost for obtaining the benefit of reduced congestion. Collecting movement information through GPS-enabled phones also help individual commuters gauge their own positions with respect to roads, bus stations and railway stations. Some smartphones-based applications enable the commuter to know how long it will take to reach a particular place, say a train station, whether parking spots are available at their destination, and when the next train will arrive. This information enables commuters to make individual choices with regard to their travel. The IT infrastructure used for such systems relies on openly available information such as traffic data, parking availability data, and departure data. So friends, in this video we have talked about the term smart transportation. In next video we will come with a different case study for this video. Thank you.